In this video, we're going to go over Aldol addition and condensation reactions. So in these type of reactions, you're going to have an aldehyde on the left react with a base. In this situation, is going to be this OH. This OH is going to attack one of the beta hydrogens, and I'll draw it like this so you can see it better. So these lone pair of electrons is going to reach out, take one of these hydrogens, and it's going to leave the lone pair of electrons on the carbon, as we see over here. This is called an enolate ion. It's an intermediate ion in this addition reaction. So from here, you're going to have this enolate ion attack another equivalent of the aldehyde. So this is going to do a nucleophilic attack like that, and you simply combine both of these together. And when this attacks this, you always have a flow of electrons when electrons move. So when this nucleophilic attacks this carbon can only have 4 bonds, so this pair of electrons is going to move onto oxygen. So oxygen is going to have three lone pairs of electrons like that. And then you just add the carbon, and you add your other carbonyl carbon like that. And from there you simply add water. So this lone pair of electron reaches out and grabs one of these these hydrogens off the water, and you have an alcohol. Like such. And this part is the addition, or the Aldol addition reaction. And what that simply is you have a alcohol and an aldehyde, hence the al for the aldehyde and the al, or the ald for the aldehyde and the al for the alcohol. Pretty simple. Now the condensation part of this Aldol addition and condensation, which oftentimes is on a test, you're simply going to add another equivalent of OH, and this OH is going to attack this beta hydrogen, and I'll draw it like this so you can see the electron flow. So this right here is going to have 3 pairs of electrons. One pair of these electrons is going to reach out and grab the hydrogen. When it does this, these pair of electrons here is going to go here to form a double bond. So you'll have this. You have this double bond with this carbon. You have this CH3. You have this like that. And of course, when this happens here, it's going to produce water, because this OH group is gaining a water molecule. So you have H2O. If you want to draw it correctly, you can put the lone pair here. And you're also going to have OH left over, because water was used here and it lost the hydrogen. So when you lose a hydrogen, you're going to have an OH. But the condensation part, so this is called the Aldol condensation reaction. Condensation simply means you're going to have water produced as a byproduct in the reaction, and that's what we have And that's what we have here. And the reason we use water can act as an acid or a base depending upon your situation. So in these type reactions, if you're kind of unsure, just use water. It's readily available in the experiment, wherever you do this, in a beaker or a flask or whatever. You have water, and as water is kind of reacting, you're going to form these OH and water, depending on whether it's donating or gaining a proton. And just to be clear, I kept calling these the beta hydrogens. This is actually alpha hydrogens. This is the alpha carbon. An alpha carbon is the carbon that's directly attached to the substituent. In this case, the substituent is this carbonyl group here. So you learned in earlier courses, an alpha carbon is any carbon that's directly attached to a substituent. So if you had like chlorine here, this would be like, and let's say if you had something like this would be the alpha carbon. So it's a little deceptive here if you try to compare that to that, and I still get mixed up with it myself from time to time. Just know that in the carbonyl group, this carbon is not considered the alpha carbon, but it's the carbon that's adjacent to the entire carbonyl group.